For those who are unable to join the class, that's why I'm recording. No, sir, I've not seen you in this class for as long as I can remember. Nonetheless, you're welcome. Okay, so let's continue. Now, we also talked about forming dimensions from this dimensional analysis from these fundamental quantities. We said that any other derived unit comes from this three, mostly these three, the length, mass, and time. Okay, mass, length, and time. Every three comes from them, and we denoted length as L. We denoted mass as M, and we denoted time as T. So if we start taking quantities, for example, like area normally is length times breadth, right? On a general note, is that not so?
Yes, sir.
So we
Yes.
can say, but
Yes, sir.
breadth is the same thing as length. So we can say length times length. So the dimension for area is L square. L square. Okay. And if you want to bring out the unit for SI unit for length is meter. So therefore the unit also becomes meter square. Okay. If it's for volume, if it's for volume, start to take for volume. Please permit me to do something to avoid taking extra spaces. If it's for volume, volume is usually length times breadth times height, right?
Yes, sir.
Length times breadth times height. Breadth and height, all of them are still length. So it's the same thing as times L times L
L time. L.
times L. Okay, and that will give us L cube. L cube. And then uh, the unit for length is meter, so we have meter cube as that given. Okay, so let's take another one. Let's take velocity or speed. Velocity or speed. What's the formula for velocity or speed? What's the formula for velocity or speed? What's the formula for velocity or speed?
You know the formula.
You don't know the formula for velocity or speed?
I'm asking.
That's serious. The formula for velocity or speed is distance over
That distance
time.
over time.
And if
Shut
speed is
up.
distance over
Let's
time,
see.
then if its velocity is displacement over time, okay? Distance is the same thing as L, right?
Yes.
L time is T. So the dimension for that is L T raised to the power of minus 1.
One.
Raised to the power of minus 1. Okay? Let's bring it up properly. So let's pick another one. Acceleration. Acceleration. What's the formula for acceleration? What's the formula for acceleration?
So velocity over time.
Good. Velocity
Time.
divided by time. Or change in velocity over time. So velocity divided by time. We have already gotten velocity at L T raised to the power of minus 1, right? So we don't need to calculate that again. So that is L T raised to the power of minus 1 times divided by T. Let me copy it down. So we have that divided by T. So at the end, what would that give us? That will give us L
L
T raised to
raised
the power of
to
what?
raised to power 2
Minus or plus?
plus
Not plus is minus, so you end this is very well.
minus
So it's minus 2. Okay? That's the dimension for acceleration. While the unit length is meter, c is seconds, so that will be meter per second square. That's how we are getting all those formulas from. Okay. I hope you understand. Any question before I move on?
No. Shut up.
Are we all okay?
Go and
Please mute
lie
yourself
down.
while you are speaking. This Ibifiri Allison, who is that person? Ibifiri Allison, who are you? Okay, Esther, all right, okay. Success, can you hear me? Princess, can you hear me? I hope you can. Okay, I hope you can. All right, so let's speak
Yes,
on
sir,
a.
I can hear you.
All right, good.
I can hear you. Yes.
Okay.
Yes.
Okay, let's speak on another unit. Force. What's the formula for force? Formula for force is mass times acceleration.
Acceleration.
Yes, mass times acceleration. Okay, so mass is measured in m, right? So we have m times. We've already gotten acceleration as this. We have already gotten acceleration as L2 to the power of minus 2. So if we do a multiplication, the dimension for force will be m
ML
L mlt
zero
to the power
T
of
raised to power minus two.
to the power of minus 2. Let's still move on. Let's take another higher one. Let's take work done. Let's take work done. Work done. Do you remember the formula for work done? Work done is force times
Force
distance.
times
Yes,
distance.
So that's force times distance.
force times distance. Now we have gotten the unit for force already. The dimension for force already as mlt to the power of minus 2. So we don't have to start breaking it down again. So we say that will be times. Distance is L. So we can say times
So MLT
L.
raised to the power.
What would that give us?
Power minus three.
MLT raised to power minus
Raised to
3.
power minus
Sorry,
two.
Yes.
sorry. ML raised to
L
power 2.
M ML ML
ML
square raised to
squared.
power T raised to power minus two.
ML squared T raised to power minus 2.
Yes. ml squared t raised to the power of minus 2. That's that for work done. What about power? If we are to take power is the formula.
Power is MGH over time.
That's work done over time. Work,
Oh,
work done.
ML
Depends on
squared
the kind of
T.
work done. Work done and energy is the same thing. Work done or energy over time. The work done
Okay.
or energy. So if it is potential energy at that time, that's when it will be mgh over time. Do you understand?
Yes.
Yes, sir.
It's not that the general formula is mgh. It depends on the type of work done or type of energy. If it's kinetic energy, you use kinetic energy. If it's electrical energy, you use electrical work done, electrical energy. But the general formula for power is work done over time. And we have already
Okay.
gotten the unit for work done here as ml of this. So that will be,
ML T raised to power minus 3.
yes.
Mhm.
Once we divide this by t, that will be equal to m. That will be ml t raised to the power of minus
T
3.
raised to power
Okay.
minus
I hope
three.
you understand. I
Yes.
hope you
Yes, sir.
Yes.
understand. So that's
Yes,
how
sir.
the that's
Yes,
how
sir.
you calculate the uh that's how you calculate the dimensions for anything. If I'm to take another one, let me add on that one. Let's take momentum. You've not dealt with momentum before, so let me just bring it up to you. Don't forget momentum. The general formula for momentum is mass times velocity. That's momentum. Okay, mv, mass times velocity. That's what gives you momentum. We have mass as m, and we have velocity as lt raised to the power of minus 1.
Minus 1.
So the dimension for momentum will be m.
MLT raised to power minus
Well,
1.
T raised to power minus 1.
Okay. Don't forget that we may meet it in your exam tomorrow. Okay, mlt raised to the power of minus 1. Or you remember
T
the formula
raised to
for
power
momentum.
minus 1.
Or know that momentum is equal to mass times velocity, so that you can be able to calculate it whenever if you are asked to do that. Okay, so that's that I wanted you to remember about it. Okay.
Yes, sir.
What's acceleration? Acceleration is the increase in velocity, right, per particular time. Is that not so?
Yeah.
Okay. What are the
Yes, sir.
Yes.
distance over velocity is
Time.
the right? Okay, so don't forget
Yeah.
that also. Let's move on to circular motion. Something we talked about in circular motion. I'm just going to
Wait, I said velocity is distance over time.
velocity is displacement. Distance and
Oh.
displacement is
Over
the same
No,
thing.
time.
I
you
explained
said
that to us in the
distance.
last class.
No, so I was like trying to correct you because
Oh,
you said
okay, I'm sorry if I
distance.
said that. Okay. You should know the difference between displacement and distance. I hope all of us are familiar with the difference between velocity and between displacement and distance. Is there
Yes,
Yeah.
anybody
sir.
that does not remember the difference between between distance and displacement? Anybody? Is there
Not
anybody?
really.
Okay, so I hope we all remember. All right, so let's move on. Distance is just the the space between 2 points. Okay, you're not considering direction, but if you now decide to add direction, for example, like I always say, if someone calls me and asks me where is so and so person, and I tell the person is 2 meters away from me, I've given the distance away from me. But the question is 2 meters to where? Is it to my front, to my back, to my left, or to my right? Okay, but if I say that this person is 2 meters in front of me, or 2 meters to the north, 2 meters to the south, 2 meters to the east. I've added a direction. That distance becomes a displacement because direction has been added to it. Okay, so don't forget that. Now, when we talked about circular motion, we one of the things you should note about circular motion is that apart from the fact that it's a motion around the circle, one of the things you should remember about circular motion is that circular motion is the only kind of motion where you have constant speed at all the points, yet there is still acceleration. Okay, you have constant speed all around the points in the circular motion, but uh, you have the you're able to have acceleration because of the change in direction of the speed. Because of the change in direction speed, that's why you're able to have that acceleration. And the linear velocity we are talking about is always tangential to the circular motion. It's not moving inside the circular motion, it's not moving outside the circular motion. It's just touching the tip and tangential to the circular motion. Okay, so don't forget that. Now let's go to the formulas that we can bring up from circular motion. One of the formulas we can bring out is that V, linear velocity, or angular velocity, angular velocity denoted by W omega is equal to theta. I don't know how to bring out theta. This theta divided by time, which is the angular displacement, okay, divided by time. Then, if you want to relate linear velocity and angular velocity, the formula is V is equal to WR, where V represents the linear velocity, W, of course, represents the angular velocity, and R represents the radius. the radius of the circular motion. Okay, so if for example you are told to calculate the linear velocity where you are given the angular velocity and given the radius, that's the formula to use. Or you are told to calculate the angular velocity and you are not given theta, instead you are given linear velocity and given radius, that's the formula to use. So if you are told to calculate the angular velocity and you are given the radius, that's the formula to use.
Go and watch cartoon. Go. Go and watch cartoon. Go. Go now. Go. Go. Get out of here. So now, get out.
I'm sorry about the network, I went off, sorry about that. Can you still see what I'm presenting? Is it still popping out?
Yeah, yes, sir.
Okay,
Yes.
Okay, sir, I just left.
it's not showing again. Okay, so let me go back to
Yeah.
present it. Okay, all right. So I was saying that from the formula, V is equal to WR. V represents the linear velocity or the linear speed. Okay, the linear speed, the linear velocity. W represents, or omega is representing the angular velocity, while the radius represents the radius of the circular motion. So I said if we want to make um, W the subject of the formula from this one I gave you, what's it going to be? If I want to make that the subject of the formula, what's it going to be? Are we still together? Can you still hear me?
Yes, sir.
So what's it going to give us
Yeah,
if
if
we
you're
make, yeah, making W the subject of the formula?
so that would be V W equals to V over R. That's linear
Yeah,
velocity over radius
good. Okay, that will be linear velocity all over
over
Something. I
radius.
didn't. I didn't hear what you were saying.
I said, look at the formula now given there. V is equal to WR. V is the linear velocity, W is the angular velocity, and R is the radius. So if we are making W the subject of the formula from there, we are going to have W as equal to V divided by R. Okay, that will be the formula. So if you are given a question to calculate angular velocity and you are given the linear of the constant speed and you are given the radius, that's the formula to use instead of using this theta divided by t. Is that clear? Is that clear? Is that
Yes, sir.
clear?
Yes.
Good.
Yes.
Good. Now, another thing I would also want you to remember is the equations of motion. Those equations of uniformly accelerated motion, we generally call them equations of uniformly accelerated motion. Uniformly accelerated motion. Okay.
Mm-hmm.
We have about 3 or 4 of them. One of them is V is equal to U plus AT, right?
Yes.
Yes, sir.
Who can remember the other one?
V is equal U plus 2AS.
It is V square
Sorry,
is
V square equal U plus 2AS.
U square plus
V
2.
square equals U square plus 2AS.
Yes. V square is equal to U square plus
Plus 2AS.
2AS.
Then the
Okay.
other ones are like opposites.
The other one is S is equal to UT
Yes, sir.
plus half AT.
80.
Yes. Okay, so when you are given an uniformly accelerated motion, let me state the terminologies. V is equal to final velocity. V is equal to final velocity. Okay, U is equal to initial velocity. Initial velocity. A is equal to the acceleration. A is equal to the acceleration. Are we still together?
Yes, sir.
Okay. A is equal to the acceleration. S is equal to the distance covered. And T is equal to the time. Okay, so when you are facing such questions, it depends on what you are given. If the body is starting from rest, what will you be? If the body is starting from rest, what will the initial velocity be? If the body is starting from rest, Esther, what will the initial velocity be?
0.
0.
0.
If the body is starting from rest, the initial velocity will be 0. Okay, so
Zero.
if you are going to calculate velocity when you have acceleration and time,
Zero.
then you use this formula. But if you are not giving time, but you are giving acceleration and distance, if you are giving acceleration and distance, and they say calculate final velocity, and the body was starting from rest, that means your U is already 0. You have acceleration, you have distance covered. That means the second formula is what you are going to use.
That's your
Okay.
homie.
But if you are giving the initial or starting from rest, you are giving acceleration and giving time, and they say find distance. Okay, it depends on what you are giving. What you are giving depends on the formula you are going to use. Is that clear? Is that clear
Yeah.
on
Yes,
that?
sir. Yes,
So
sir.
I
Yes,
want you
yes, yes.
to take this question now. I'm going to type it, and I want you to try and do it for me. Okay. Let me post this question. Let's use here as 5. All right. So I want you to calculate this for me now. Are you seeing the question? Are you seeing the question?
Yes, sir.
Okay. I want you to try and solve it for me now. Solve it and give me the answer. So which of this now do you think you can use here? Which of the equations of motion are you going to use from what you are given? Is it the first, the second, or the third one?
Mm.
The
Sir, the,
first.
the first.
The
The
first.
first. Are you giving time? You need time. Are you giving time?
The second. The second. The second.
Sir, second. V square equals to U square plus 2AS.
Yes. Because you are in the question, you are giving acceleration and you are giving distance, right? And you are told the
Yes, sir.
body starts from rest. That means the U is 0. Is that not so?
Yes, sir.
Are all of us following? Please unmute yourself. Let me get the
Yes, sir.
response.
Yes, yes.
They
Okay,
not
let's
say two
continue.
times.
Sir.
Okay. All right. So in the question, we are given acceleration as 5 meter per second, 5 meter per second square. We are giving distance s as 9 meter, and then you are giving u as 0 meter per second. So using the formula v square will be equal to 0 square plus 2 times 2 times 5 times
times 9,
9. Okay.
90,
So that will give us what? 90, right?
90.
So v
Yes,
square
sir.
is equal to 90. V square is equal to 90. So
It's
to make
90.
v square of the formula, what do we do?
We
We
look
take
for
the
the
square root,
square root.
right?
Yeah.
Yes. So
So we
what's
look
the
for
square
the
root of
square root.
90?
You transfer that.
So what's the square root of 90?
Shall I be in short form?
If you want to leave it in short form, no problem.
So
But the exam,
9.48.
it may be
So
good in case you calculate
9.48.
for, yes, 9.4, approximately
8.
9.49.
9.49.
Approximately
Nine.
9.4.
Question.
I said 9.2.
Okay, Esther, I can hear
So
you.
9, not 4. So 9.49.
Okay, got it. Esther, you said you have a question. I'm listening.
Then in the solution, so where did you get? Okay. So where did you get two from?
Now, they told you the body was at rest from the question. Is that also a body accelerated uniformly from rest, right?
Yes, sir.
When a body is at rest, the initial velocity is what?
Zero,
When a body,
zero,
yes, whenever you see
zero.
rest in any question, whenever you see rest, just know that the initial velocity of that body was 0. Okay, unless you are given that a body accelerates from a velocity of so so and so. If that's not the case, if you are told from rest, just know that the acceleration it had before was 0. Exactly.
Yeah, but say where
Yes, sir.
did you get from? The two is the two. Like you added, you said 0 plus 2.
Look at the formula now. The formula says v square is equal
Okay,
to v
okay,
square plus 2as now. That's the
okay,
formula. The formula, I didn't get it from any other place.
okay.
Okay. So please don't forget that. So that's the equations of motion. Okay. Whenever you are giving uniformly accelerated motion, those are the questions you use. Any question? Any
No,
question? Okay, good.
no.
All right. Next thing we talked about was types of motion, and we talked about random motion. Okay, we also talked about rotational motion. We talked about translational motion. We also talked about oscillatory motion. Okay, and the last one we did mention was relative motion. Okay, and I told you, although we can classify relative motion as a type of motion, a body cannot undergo relative motion. You cannot say this body is undergoing relative motion. It's not possible. Okay, because relative motion is the motion of one body in relation to another. For example, like I said, if a train is moving or a plane is moving, and then I begin to move inside the train, my movement is related to the motion of the plane. Or as we are moving around the earth, also, the earth is also moving. So our motion is also relative to the motion of the earth. That's what we mean by relative motion. But you can't point to a body and say this body is undergoing relative motion. Okay? So while it is a type of motion, a body cannot undergo relative motion. Is that taken? Is that well understood?
Yes, sir. Yes,
Yes,
sir.
sir. Yes, sir.
So these are some of the things we did in first term.
Yes.
Now I know heat is a type of energy, right?
Yes,
Yes.
So what's
yes.
the SI unit? What
Yes,
will be
sir.
the unit? The unit for
Sir
heat is
Jules.
joules. Okay, because heat is a form of energy. That's why the energy, this thing is joules. What are the types of mechanical energy we have? We have types of mechanical energy. What are the two types?
Electromechanical.
The types of mechanical. Alfred, tell me.
Kinetic and potential energy.
We have kinetic and potential energy. Okay, so when a body is moving, what kind of energy does it possess?
Kinetic energy.
Kinetic. But
Kinetic.
when it's at
Energy.
rest, When it's at rest, it's possessing
Potential.
what type?
Potential.
Potential.
Potential energy. Okay, so those are the two types of this thing you can should remember. Now, one other thing that I didn't talk about much in your discussion last time was temperature and temperature conversions and all that. I was using the wrong unit in your SS1, so we didn't talk much about that. So let me just quickly introduce temperature to us. Just quickly introduce temperature to us. Okay. The SI unit for temperature is Kelvin, but there are other units we use such as Celsius and such as all that. Okay, so to convert from degree Celsius to degree Kelvin, let me use X to represent Celsius. Okay, if you want to convert Celsius to Kelvin, then the temperature in Kelvin will be equal to will be equal to the temperature you had for Celsius plus 273. Okay, the temperature you had for Celsius plus 273. That's how you get the. That's how you can calculate the. That's how you can convert from Celsius to Kelvin. So if your X is equal to 0, okay, what will be your Kelvin? What will be the temperature in Kelvin? 0 degrees
100.
Celsius is what? 0 degrees Celsius will be what?
Minus 27 degrees.
Is it minus or plus?
Plus.
Sir,
If x is
minus.
no now if x is equal to 0, that means this place will be 0 now. So 0 plus 273 will give us what?
Okay.
7.
0 plus.
0 plus
That will
273.
give
273.
us 273. 273.
Yeah, to give it 273. Okay, so that's the this thing. What's the boiling point of water? What's the
100.
boiling point?
100.
100. And what's the icing point? What's the
So,
icing point?
so what do you say the boiling point of water is? I didn't hear you well.
100 degrees Celsius.
Okay, sir.
So when you are converting it to Kelvin, it becomes 100 plus 273, which will give you 373. The icing point of water is 0. So if you want to convert it to Kelvin, it will be 273 degrees Kelvin. Are we clear on that?
Yes, sir.
All right. That's just one of the things that I also wanted you to know. I would also want you to try and read up thermal expansivity. I also want you to read up thermal expansivity, uh, area expansivity, and cubic expansivity. One of the things we talked about also, thermal expansivity. Okay. And if it is linear expansivity, linear expansivity denoted by alpha. I can't write out the symbol, but I know the symbol of alpha. Okay, is change in length. That's L2 minus L1 divided by. Let me see if I can write it in an equation form. Let me see if I can write it in an equation form. Okay, so we have. Just hold on a minute. We have L minus. Coming, it's taking a long time. Minus L1 divided by the increase in temperature divided by L1 times theta 2 minus theta 1. Who is that? Please hold on a minute. I'm coming. Yeah, AB. Alpha. All right, so that's the formula for calculating uh, linear expansivity. Okay, L2 represents the final length. L1 represents the original length, while theta 2 and theta 1 represents the final temperature and the uh, initial temperature. Okay, are you following me?
Now, please throw a question on linear expansivity.
Sorry,
Please
I didn't
throw a
get you.
question on linear expansivity.
Okay, I will. Let me just do the rest. The formula for area expansivity is similar to linear expansion, just that it is A2. Let me bring this down. A2 minus A1 divided by A1 into change in temperature. Okay, then if it is volume expansivity, note A2 is the final area. Okay, A1 is the initial area, while theta 2 is the final temperature and theta 1 is the initial temperature. When our gamma is equal to, in this case, it will be V2 minus V1 divided by V1. Okay, that's the formula we use in this case. Are we okay with it? Are we okay so far? Are we okay so far?
Yes.
Okay, so let me bring out a question on any
Yes,
of
sir.
them. Let's attempt them and see. Okay. Let me look for a question. Okay. Let's try this one. Let's try this one. Okay. Now in this question, it said a metal sheet of area 100 cm cube was heated to 70 degrees centigrade.
Now, please
Calculate.
repeat yourself.
The question is before you now. The question is there.
I didn't see it.
A metal
Yeah.
sheet of 100 cm cube was heated to 70 degrees Celsius. Please, someone is knocking at my door. Be copying the questions. I'll be back. Yes.
Yeah.
They are attempting the questions. I'll be back.
Wow.
How many of you have been able to solve it? How many of you have been able to solve it?
Cannot me.
Okay, my system battery is even running low, so I have to rush up. Let's quickly do it. You are looking for, they gave you A1. You are given the initial area of the sheet A1. You are given theta 2 minus theta 1 heated to 70 degrees Celsius. That means that the increase in temperature, that's theta 2 minus theta 1, is actually 70 degrees. You are told to calculate the area if the linear expansivity, okay, they didn't give you volume expansivity, they gave you linear expansivity. Now the relationship, if you remember, I gave you relationship between them. Let me use B for this. V is actually equal to the volume expansivity is actually 3 times, is equal to 3 times the linear expansivity. Okay, and the area expansivity is equal to 2 times the linear expansivity. Okay, so if you are given the linear expansivity to calculate the volume expansivity, you just need to multiply by 2. To convert the linear expansivity to area expansivity, you just need to multiply by 2. So you are trying to make V2 subject of the formula. So put it into the equation first and solve. Are we together? Are we still together?
Yes. Yes, sir. So I want to ask you a
Alfred has
question.
given me the answer. Yes, I'm listening. What's the question?
Okay. Sir, is it the first area that they show you? That's the A1.
Yes, they say this is the initial area. That's the original area of the metal sheet. Now they now,
That's the first area that is in the
yes,
that's the first area that is in the question.
yes. Okay, that's the
Okay,
A,
sir.
that's the A1. That's the original area. So now the thing has now been heated. It will expand, of course, and have a new area. What's the new area? 8. So that's what you are calculating. Okay, Alfred has gotten his answer.
Okay.
There is no time. My system is down. So I want you should be able to manipulate that on your own. Is that also?
Sir, just solve it.
Okay.
Mm.
Sir, just solve it.
If you make V2 the subject of the formula here, if you make V2 the subject of the formula, come in. Just give me a minute. If you make V2 the subject of the formula, what are you going to have? V2 will be equal to the volume expansivity V, which is supposed to be gamma, times V1 times V1 into theta 2 minus theta 1, which in this case is 70. Theta 2 minus theta 1. Okay, theta 2 minus theta 1 plus, because when the V1 crossover, plus V1. Okay, so you can get your, sorry, this is not V, it's supposed to be A. Since we are calculating area expansivity, sorry, the area expansivity A.
Okay.
Area expansivity A. Not, it's not V, it's A. So
Okay, sir.
A2 times the linear expansivity B times V1 into that, okay, into A1. So this is the formula. Just calculate it on your own quickly and get your answer. Alfred has gotten his answer. He got 109. Don't change. If you change the degree to Celsius, it won't change anything, Joanne. Huh? My battery may go off very soon. And if that
True.
happens,
So just explain it.
I've explained it already and I've given you the formula to use already now. Your linear
Just solve.
expansivity, eh? I'm
Sir,
typing, you know,
sir, I
Just
don't,
solve.
sir,
I'm listening.
sir. So that gamma is representing as the metal.
That's gamma B. This, yeah, beta B is the area expansivity, but you are given the linear expansivity. And I said the area expansivity is 2 times. That B is equal to 2 times of A. So to get the linear expansivity, to get the area expansivity, multiply that
Okay, I understand. I
Celsius
understand.
times times 2.
Okay,
Then
I
the theta
understand. I
2 minus
understand.
theta 1 is already given as 70. You don't need theta 1 and theta 2 separately. Yeah, I've already told you that theta 2 minus theta 1 is 70. That's the meaning of 270. That means the increase.
Okay, sound. I understand.
Uh-huh. You don't need to change it to Kelvin. Joanne, just got power. We are lucky. So my system won't go off again. Oh, it's okay. The system is back online, so shouldn't I be afraid of going off? Are we okay with that? Or are we all solving? So Joanne, you heard me. You don't need to change it to Celsius. Don't need to change it to Kelvin because the increase won't change anything. Desire that sound from your end. Mute yourself unless you are speaking to us now, so we won't get those squishy sounds. Are we all attempting it? Esther, is Esther still here? Is Esther still here? Okay, I've seen your answer, Kingsley. You got the same answer as Alfred. The rest of you, are we still solving? The rest of us, are we still solving? I'm not getting your responses, so are we still solving?
Yes, sir. I'm still solving. Which is sound coming from now?
Let me mute Desire. It's like that's where the sound is coming from. Please only unmute yourself when you want to speak. Only unmute yourself when you want to speak. Okay. All right. I feel with Princess. Are you still here? I've not got heard from you at all in this class. Samatek, if you are not speaking, mute yourself. Oh. Except you want to talk to me. Ben's Princess, are you in this class at all? Okay. All right.
In the class too.
I've not heard from you. Have you been following?
Yeah, because where I am is kind of noisy.
Okay, no problem. So I'm hoping all of you can calculate this. So I want to move on to talk about something else. Now we did talk about modes of heat transfer. We did talk about mode of heat transfer, and we talked about conduction, we talked about convection, and we talked about radiation, right? Do you remember that?
Yeah, right. Yes, now.
Yes, sir.
Conduction. Okay, and conduction is the one where it has to have a physical contact with the body, and there's actual with the heat flows without actual movement of the body. Okay, while for conduction, even though it's having a physical touch with the source of heat, the atoms or the body still has to flow from one part to another before the heat can move. While for radiation, there don't have to be any form of this thing touch between or contact with for the heat to flow. And I did mention that one of the things that we can use to measure radiation is something called a radiometer or a thermopile. Please don't forget this. The device that is used for measuring radiant energy or radiation, okay, is called a radiometer or a thermopile. What did I say it is called?
Radiometer or
You need
thermopile?
our government.
Thermopile. Don't forget that it's used to measure.
Radiometer.
It's used to measure. It's used to measure radiant energy. Okay, so don't forget that. Still talking about heat transfer. In convection, I tried to explain to you that how water boils. Convection only happens in liquid. In liquid, doesn't happen mostly in solid. Part will go up, polar part will come down. That's how it will keep. Hello, mama, call me back at the class. I hope I've not lost you. Okay, we are back together. And see breeze. Okay. Convert from Celsius to Kelvin in this particular question. Do you know why? It is the increase that is 70. You are not giving the initial temperature, you're not giving the final temperature. It is the increase in temperature that was 70. If the increase in temperature was 70 in Celsius, the increase in temperature will also be 70 in Kelvin in Celsius. So 20 degrees Celsius is now 90 degrees. Are we still hearing me? Okay.
Yeah.
If it was 20 degrees Celsius and it's now 90 degrees Celsius, it's increased by 70, right? So let's convert it to Kelvin back and see. Uh, 20 plus 273 will give us about 293. And when it's now 90 plus 270 will still give you that. When you subtract the initial minus the final in Kelvin, so it will still be 70. That's why it won't make any difference. It's only when you are giving in this, the increase will still be the same, the change will still be the same. So I hope you understand that. Okay. All right. So let's go back to what I was talking about. All right. So one of the ways we see convection is in land and sea breezes. Okay, is in land and sea breezes. Now, in the night, sometimes if you're close to the sea, you feel breeze blowing from the sea. What actually happens is warm at night when and then the sea is cold. Okay, because of that convection, the sea breeze will now flow because it has now become less denser. It will now flow to the land, while the land hot breeze will flow to the sea to get cool. That's how they will keep rotating. That's how they will keep rotating. That's how they will keep rotating. The hotter breeze in the land will flow to the sea, and
Yes,
the
sir.
colder breeze in the sea will now flow to the land. Okay, so sea breeze is when wind blows from the sea to the land. That's what we mean by sea breeze. Okay, it's another way we can demonstrate convection. Now, in radiation, we talked about that some surfaces radiate energy more than others. I would say that black substances or black surfaces, they are good absorbers of radiation, right?
Yes.
Black substances, good radiators, sorry, absorbers of heat. Okay, while silver-like or white surfaces are good radiators of heat. Okay, they radiate it, they give back heat. They are poor absorbers of heat, but they are very good radiators of heat. So don't forget that. I would also want you to go and read up, still on thermal expansivity. Go and read up you may want to write this down. Apparent and real cubic or volume expansivity. Okay,
Sir, please repeat
apparent and real
yourself.
volume or cubic expand apparent and real volume expansivity.
Apparent and what?
It's in your textbook. Go and read it up. We don't have the
Sir,
time to.
apparent and what?
Real, reality, real volume expansivity or real cubic expansivity. Okay. All right. The class is getting smaller and smaller. I don't know the reason why. Okay. Let's move on to a device that converts mechanical energy to electrical energy. What do we call it? A device that converts electrical energy to mechanical energy to electrical energy. An example of such device is what? Your generator in your house.
Wait,
Generator in your house, as it's turning its mechanical energy, is converting it
Yes,
to
sir.
electrical energy through the principle of electromagnetic induction. What about your battery?
a car,
Your eh?
a car,
Your battery converts its energy to which one?
Sir, yes, sir, it's the same thing.
No, your battery converts chemical energy to
Oh,
electrical
okay.
energy, while your generator converts mechanical energy
Mechanical
to
energy.
electrical energy. Okay, don't forget that.
Okay.
Electric
Yes, sir.
motor converts electrical energy to mechanical. It's not the same as a generator. An electric motor will receive electrical energy and convert the electrical energy to mechanical energy. But a generator will convert mechanical energy to electric energy. Okay. Now let me explain this thing once again. When we talked about conservation of energy, I explained that to us in the last revision class we had last week Friday. I said if a body is at a height, all the energy it has is purely potential, right? And when you release that body, it will begin to convert that potential energy to kinetic energy until it touches the ground. And just before it touches the ground, it has converted kinetic energy. So if a body was, I hope you know the formula for potential and kinetic energy.
Yes,
The
sir.
formula for potential energy is mgh, while the formula for
Yes, sir.
kinetic energy is half mv square. M is the mass, v is the velocity. Okay. So if you are told to calculate the kinetic energy of a fluid, I hope I'm not
Meeting done.
are we still together? The network from my end.
So I'm not hearing you again.
Seriously, yes, I'm coming. I don't know if my data has finished or something. Just give me a minute.
Okay.
Can you hear me now?
Yeah.
Can you hear me now?
Yes. Yes.
Can you hear me now? Okay. All right, good. So I hope you understand what I just explained about that solving.
Yeah.
Do you understand what I just explained about that
Yes.
solving? Okay. So please quickly rush up to work energy and power. Okay, go and read go leave electroscope. Okay, go leave electroscope. And don't forget that one of the topics we did this time were fields, vector fields and scalar field. And under vector field, we have all the force field. We have the gravitational field, we have the electrical field, and
Magnetic
we
field.
have the magnetic field. Okay, gravitational field
Sorry. Uh, uh,
the network keeps disturbing, coming in and going off, coming in and going off. I'm sorry about that. Okay, go and read up a particulate nature of matter. Go and read up all those atomic number, isotope, blah blah blah. Okay, don't forget to read that up. But I really want us to move on quickly to please go and read elasticity too. Work
okay,
done in
sir.
an elastic field. Please don't forget that. Read elasticity. Work done in elastic field. Those elastic limit, breaking points, yield points. Okay. Do you
Yes, sir.
understand? Are you hearing me?
Yes, sir.
Uh-huh.
Yes, sir. I'm
And
hearing you.
also that cohesion and adhesion. Cohesion is the force of attraction between molecules of the same type, while adhesion is the force of attraction between molecules of different type. And why water wet glass and mercury does not wet glass. Also go and read up on surface tension. Okay, surface tension, and also read up viscosity. One of the things that makes a lubricant very good as a lubricant is because of its viscosity. The oil we use
Yes,
as
sir.
lubricant, we use them as lubricant because they have a very good viscosity. They have a very good thickness. That's why we use them. Okay, so don't forget all that also. Okay, and also when we started talking about electric currents, when we talk about electricity, we mentioned that please, I'm rushing because of time. That current is the amount of charges that flows in a conductor by a particular time, right? Is the time
Yes,
rate
sir.
of flow of a conductor. Okay, so please don't forget that. So that's I is equal to Q over T. I is equal to Q all over T. If you are given Q and T and they say find I, you should know what to do. Q represents the amount of charges measured in coulombs. So if you are told to calculate the amount of charge, that means Q will be equal to I times T. And your T should always be in seconds. Okay, don't forget that. We also went on to talk about electrical resistance. And I gave you a symbol. We have two types of resistors. We have the variable resistor and we have the fixed resistor. An example of the
Yes.
variable resistor, it's a rheostat. A rheostat or a resistant box is an example so of a variable resistor. So please go and read up on that also. Read up the symbols. Read up the symbols and go and know how to calculate when resistors are arranged in series and when resistors are arranged in parallel. How do we calculate them? Okay. Are you listening to me?
Yes, sir.
Yes,
Okay.
sir.
All right. So please go and read that up. I don't have. If you're having any difficulty between now and the exam tomorrow, can we have another class early in the morning tomorrow by 8 or so before the exam
Yes, sir.
starts? Would that be
Okay.
possible?
Okay, sir. Yeah. Okay, yes, sir. From maybe like from 8 to 9. From okay, yes, sir. Before the exam.
Yeah, 8 to 9. I think that would be good. Okay. So I
But on
believe we should.
WhatsApp, let it be on WhatsApp.
Sorry.
Let it be
On
on
WhatsApp.
WhatsApp.
On WhatsApp will be
Yeah.
very slow. On WhatsApp will be very slow. IJ, I just joining us. Okay, she has left. Okay, and WhatsApp will be very slow, and I have to be cutting and cutting and cutting and cutting, and I'll be able to explain the questions as expressly as I want to. Okay, I have to be recording voice notes. I don't know if you understand or not. That's why I said let's do this. You'll be seeing the questions. You'll be asking me. I'll be explaining it to you. I feel this is the best. Okay, WhatsApp is not really a teaching platform. It's just a chatting platform. Okay, so also go and read work done in an electric. We'll look clearly at electricity. A lot of the questions deals with electricity. That last part of what we did. Okay, so please read up electricity. When we meet tomorrow morning by 8, please, I may forget to one of you can remind me. Okay, in the morning, either
Okay.
call me or something to remind me in the morning so I won't forget. We'll use that whole time to deal with electricity, all those electricity calculations before your exam. Because a lot of your exams deals with those calculations. Is that okay? So are we all agreeing to
Yes, sir.
meet? We
Yes,
all
sir.
agreeing in the morning
Yes, sir.
tomorrow.
Yes,
Yes.
sir.
Okay.
No,
Okay.
I'm not
So are
a
you in agreement with us?
increasing it.
Okay. So I believe we can close here, right? I can see
Yes,
your
sir.
team already waiting for you. All right, so we
Okay.
can
Yes.
close. Your economics teacher is calling, so you can join in up now.
I think it's one.
All right, so you're free to leave
So
it.
I don't know.
You're free
Okay.
to leave now.
Everybody is not. I'm not going. Oh, teacher, I'm not going. Ooh,
Samatek, are you talking to me or someone else?
there is not here.
All right, now leave. You can leave now and join your economics teacher. We'll meet tomorrow morning. So bye for now.
Bye, sir.
All right.